joined it, were with us and participated in the fall or in December when we had the first presentation. And this is, as Andrea suggested, very much a follow-up from that. And what we're going to do today is just quickly remind those of you that were here last time about what we were doing and what we did. And for those that weren't able to participate last time, it'll give you a quick introduction to the project, but we're going to go through it pretty quickly because we'd like to get to some of the discussion points at the end, which is really our focus for today. As a quick introduction, this is part of a project funded in part by Agriculture and Agri-Food Canada with the Canadian Wildlife Health Cooperative to really try to, in general, improve on our surveillance database and the surveillance data that we are collecting. And so there's a whole host of reasons why we are interested and need to do that. And this presentation and this project that Michelle's been working on is one part of that larger project to really improve our wildlife health surveillance across Canada. And so our goals with that project, and it's called the Wildlife Health Information Platform, are really to manage data better, identify use new information, and do more with the data we have. And in this particular case, we're using wild bird avian influenza as a model for that. And one of our main reasons for that and why we chose avian influenza is there's been quite a lot of surveillance, both in live birds and dead birds, or dead and alive wild birds, and some domestic birds as well. There's been a lot of data collected about sort of prevalence and distribution of those viruses, some work on the different strains of the virus that are present. But our question was whether that was actually changing any practices, whether we could do more or better surveillance for avian influenza that would really be of more benefit to producers and policymakers, that would give them a better idea of threat level or what we need to know or where the virus is moving and that kind of thing, rather than just sort of prevalence of the virus in our wild bird populations year over year. So with that, I might turn it over to Michele to run through a little bit more of the project.
Thanks, Jane. So I'll be going through the review of the methods and what we accomplished last meeting quite quickly, but I do have some sort of stops planned so people can ask questions or make comments as we go along. So when we decided to use avian influenza as our model for developing the WIP, that provided the additional objective of using it as an agricultural threat evaluation tool. So our question for each week of this retrospective is, what is the threat level for AI transmission from wild birds to domestic poultry at our study sites? And we had the goals of developing the new information technology to access and analyze data from diverse sources for all wildlife diseases, and then improve, as Jane said, to improve our surveillance to accommodate faster agricultural threat detection, and hopefully with that information inspire producers to enact earlier and effective biosecurity decisions. We wanted to be able to use data that's generated online, and as well, although we haven't done it for this project, is use citizen science for producers to also improve our threat detection. So this project was funded by Agriculture and Agri-Food Canada largely, and it ends in 10 days, as well as support from Chicken Farmers of Canada, Turkey Producers of Canada, Canadian Hatching Egg Producers, the CFIA, and Environment Canada. So thank you very much to all of our funding agencies. Next slide, please. So this is a schematic of the WIP. Health intelligence, or health information systems, combine information from a number of sources, and they use the term sensors. So the data sources that are at the top. On the left, the environmental data. So that's environmental conditions that provide suitable habitat for waterfowl, and it's also known to increase avian influenza survival in the environment. The middle one, the indicator-based components, are the traditional surveillance that's carried out. So for CWHC, it's their wild bird surveillance, and CNACE is the CFIA's commercial bird surveillance for avian influenza, as well as international surveillance, and that information was gathered and sourced from CZ. The event-based components are all the other sources of information, such as ProMed and Twitter and blogs and so on. And we looked at Twitter, and then we also used information collected from CZ, collected by CZ, and I was on a listserv as well. So all of that information is collected into a data center where it's cleaned and filtered and analyzed. And if there's a signal detected, it's reported to those who need to know. But the WIP ends at that point. Any response to the signal, either preventative or control, are enacted by industry boards or the regulatory agencies. Next slide, please. So these are our two study sites. It's the Fraser Valley of British Columbia and Central Alberta, and they're very different. So we're not trying to compare between the sites, but rather to see how the WIP worked into very different environments. Next slide, please. So again, this is our question, and from a literature review and interviews, we identified three main categories of information we wanted to collect. So one was the detection of notifiable avian influenza in the world, waterfowl migratory routes, and environmental conditions. And those were the data sources we used, so CWHC and CZ, Ducks Unlimited Migration Alerts, and eBird. eBird is a citizen science checklist program for the birding community. And the environmental conditions from Weather Underground and Environment Canada, as well as remote sensing. So MODIS is a satellite sensor. It stands for Moderate Resolution Imaging Spectroradiometry. And RadarSat, which is a Canadian Space Agency program. So you will know, for those who are involved in avian influenza, that there's a lot of important information missing. When you look at the literature for changing risk levels for avian influenza, they're usually looking at overplace. So things like farm density is very important, but it's not important in this project because we're looking at two study sites, and we're looking at changing threat over time. So elements like farm density aren't included in this study. Next slide, please. So we have an aggregation of a lot of diverse information. So we really wondered how we were going to evaluate it and come up with a sort of a clear and transparent and consistent way to evaluate the data. And next slide, please. So we decided to use an additive model of a multi-criteria decision analysis, and it's called SMARTER, and the reference we used is below. So the objective part of the process was the literature review and the interviews, and that selected the data that we used. But the values of the different criteria is subjective, and that's where you guys, the subject matter experts in December, came in, and we determined those values. Next slide, please. So this is the matrix from the work we did in December. So we reviewed and revised the definitions for low, moderate, and high threat for each of the for 7 elements. And 26 participants also ranked the elements in order of importance, with one being the most important. And then from that, I normalized the ranking to establish the weight. And the math for that will be in the notes, which will be available to you later if you're interested. You'll notice that instead of 7 elements, we have 8, because we had temperature and the presence of ice and snow together. And I was just having so much trouble trying to apply the definitions or the data that we were getting to the definitions. There was just too many permutations between the two, so I had to split them apart. Next slide, please. So we completed a 6-month retrospective study, 26 weeks, started August 6th and ended at the end of January. Next slide, please. So I'm quickly going to review the definitions. Some have been modified from the last meeting. So for temporal distribution, so that's the time distribution of a detected avian influenza strain. Low is the strain's only been identified a couple times within a time-limited period. Moderate, repeated detections throughout a migratory season, so weeks to months. And high is the strain is persisting into the next migratory season, so present for months to years. Next slide, please. So the ability of an avian influenza virus to be transmitted from wild birds to domestic birds or other animal species was the next element. Low was there's no evidence of transmission. It has been identified in wild birds only. Moderate, it has been seen in domestic poultry. And high was repeated occurrence of transmission within and between wild bird populations and domestic poultry or other species. Next slide, please. For the global distribution, the flyways of the migratory birds are important. The Pacific flyway in red and the central flyway in green are the two flyways most relevant to our study sites. But you can see the Eastern Canadian flyways in blue and black overlap those, as do the Asian flyways in northern Canada. Next slide, please. So the definition for a low threat for global distribution is that an identified virus was outside Canadian flyways and did not overlap our flyways. A moderate level is that an identified virus was in a migratory flyway that overlapped Western Canadian flyways, so either Eastern Canadian flyways or the Asian flyways. And a high threat was avian influenza virus identified either in the Pacific flyway or the Central flyway. Next slide, please. So the next category was waterfowl migratory routes and the waterfowl presence. We were interested in the orders Anseriformes, which is the ducks and geese, and Ceratiformes, the shorebirds, terns, and gulls. So we focused on those two orders. The low threat was outside the migratory season, so it was just the year-round residents. The moderate threat was bird presence during the spring migration, and for Alberta, that was defined as March to May, and in British Columbia, February to April. The high threat level was during the fall migration. In Alberta, that was August to November, and in British Columbia, September to December. And fall migration is considered a higher threat period than spring migration because of the presence of immature birds who are known to be reservoirs for the virus and a source of transmission. Next slide, please. So the last category were the environmental conditions. First was temperature. In the literature, the peak period for virus transmission is from -5 to +10. So that was our highest threat category, and the other ones were spread out from there, moderate and low, being outside those temperature ranges. Snow ice presence, birds like open water and open fields so they can feed. So the low threat level was when 50% of the fields and the water bodies were snow covered. If a water body was snow covered, it was therefore assumed there was ice on it. Moderate was between 25 and 50%, and high was most of the fields and water bodies are open, so the birds are more likely to stick around. Next slide, please. Amount of surface water, and we used soil moisture as a proxy for surface water. So surface water is important for bird presence as well as virus survival. And we used a anomaly map and compared each week to the 30-year average for that week. So at the low threat level, the majority of the pixels were drier than normal, and that was like 5% drier or more. Moderate was within 5%. The majority of the pixels were within 5% of the historical averages, and high was wetter than normal. So the majority of the pixels were 5% wetter or more than 5% wetter than normal. Vegetation density, which is measured by normalized difference vegetation index, was done similarly. So each week of the study was compared to the average for the 30 years, for the previous 30 years. So low was less green than historical averages, moderate was within normal, and high was more green than average. And vegetation density is used because it's been shown that bird migration does follow changes in vegetation density. So they're showing that they have something to eat. Next slide, please. So this is our OOPS. These two elements were provided by Agriculture and Agri-Food Canada, and they are meant to be used during the growing season. So after harvest, they no longer provided this information. So next slide, please. So what we did is for Alberta, we just didn't use those two elements and just made them 0 for Alberta because winter was already well established there, so it didn't matter. In British Columbia, after early November, we substituted precipitation and used the weekly cumulative sum to a historical baseline. And for the vegetation density, it hadn't changed over the previous weeks. It was sort of within historical averages, so we just kept it at moderate for the rest of the study for British Columbia. Next slide, please. So when we ran the retrospective study, this is what we noticed. For these two elements, temporal distribution and transmission, both which are ranked quite high, because of the detection of the sort of recurrent detection of viruses in Asia, especially the H7N9 and H5N6 that popped up throughout the study period, these two elements were ranked at high threat because they've persisted over years and there has been transmission of these viruses to other animals, including people. So they were ranked at an 8 throughout the study and they didn't change. So not only did they not really contribute to the matrix or to our understanding of what was going on at our study site, but they also accounted for a large amount of the cumulative sum. For any 1 week, the maximum cumulative sum was 10, and these together were 3.6%. So they accounted for a lot of the cumulative sum each week. So it didn't really seem like they were appropriate. Next slide, please. So what we decided to do was to take the 3 elements within the category notifiable avian influenza virus detection and combine those into one element. And the first division of that element would be their global distribution so that they make sure that the identification of the virus was more relevant to our study sites. So low was still identified in a flyway that doesn't overlap Western Canada, moderate in a flyway that does overlap with Western Canada, and high within Pacific or Central Migratory Flyway. And then within each of those threat levels, we assess the following to determine the numeric value. So evidence of transmission using the same definitions as before, and temporal distribution. So for example, the identification of the H7N9 in Asia would be a moderate threat level because it overlaps the Pacific Flyway, say for British Columbia. So moderate numbers 4, 5, 6, and 7, but because the viruses have persisted over years and they're easily transmitted, I put them at the high end of the moderate level, so they were ranked 7 for British Columbia. And I put it at 6 in Alberta because Alberta's flyway doesn't overlap as much with the Asian flyways. Next slide, please. So this is what the matrix looked like when we ran our retrospective again. So detection of avian influenza was still ranked 1, was still a significant weight, like nearly 41% of the cumulative score was due to that, and followed by waterfowl presence, and then the environmental conditions ranked after those. Next slide, please. So this is bar charts of the results of the decision matrix for Alberta for each week of the study. And for now, we'll just focus on the avian influenza detection so you can see what it looks like. So it still is contributing a large amount to each week's cumulative score, and it's the blue bar for those who are trying to find their way through this graph. So, but it does seem to be a bit more responsive to what's actually going on to the total threat level for that study site. So the purple duck was the notification of H7 in a wild bird in Saskatchewan, which is within Alberta's flyways, so it was bumped up to a high threat level, but was only reported once and no transmission to other species. And then then it dropped down, and I kept that level high throughout the migratory season. After the migratory season, it dropped back down to moderate, until another notification in Ontario, which was H5, which a little bit closer to Alberta, so I moved that threat level up to a 7 at that point. It's worth noting that these notifications are just that. It's when we were notified of the virus. It is not when the sample was submitted. So for some cases, that would be weeks before we had a notice of avian influenza in a wild bird. So this is not timely information. Next slide, please. Again, just focusing on the avian influenza detection, the blue bars. So again, the presence of the viruses in Asia are significant for the cumulative sums for British Columbia. In January, there was a notification in British Columbia. I think that was an H5, so bumped that threat level up into the high threat level for British Columbia in January. Next slide, please. So before we go to answer the poll questions, I think this is a good time, if anybody has any questions or comments, this is a good time for the discussion before we leave you to answering the poll questions. Does anybody have any questions or comments?
Hi, Michelle. It's Nancy. Can you go back to one of the last two slides and just explain the orange snow and ice in August? Am I missing?
Okay, so that means that there was no snow and ice. It's a low threat level because there was no snow and ice. And that actually, British Columbia, for most of it, you can see that it's a fairly low score, or fairly, because there was no snow and ice for British Columbia at that time.
But if I'm looking at the BC one, sorry, it's Dale here, and it looks like in December you have a lower score for snow and ice than you do in August.
I'm going to have to go back and look. We have, the matrix is coming up, and we'll look at the matrix in a little bit, and because we'll just focus on the detection right now.
Okay. My other question that I had was with the notification date being used as opposed to the actual sampling date, why did you go with that?
Because this would normally be being done prospectively, and that's what you would have. You wouldn't have the sampling date, you would have the notification date. So I was trying to mimic what would happen prospectively.
Okay.
Anything else? Okay, so I've changed the definitions for avian influenza virus detection since our last meeting now, and I guess we just want to make sure that you think that this is acceptable. I think the definition should be on the poll as well, and so we'll give you a few minutes to answer these two questions.
So, Michelle, the definition is not in the poll question, it's just what's on the slide.
Okay, so do we want to just go back to the definitions then so they can see them on the slide? There.
This one? Okay. So tell me when you want the poll to start.
I think we can start now. Is everybody ready?
Okay. Michelle, this change is because of the constant level associated with the Asian. If I just want to make sure that I'm clear that that's what the change is.
Yes, it was because it was the constant level from the Asian strains, plus the fact that they were that the Asian strains were really predominating in the cumulative sums.
Right. Okay. So just as a warning for those that are still typing, we just have 30 seconds left in the poll. Okay, can you see the results on your screen?
Yep. Okay, thank you. Okay. So I guess we can go on to the next slide.
Can we stop for a second? And it's Vicki. I'm struggling over this last question. Can you go back to that definition slide just for clarification purposes? Because, okay, so it's detection. You're assessing risk of detection or risk based on the level of detection? So that's the first question I have.
It's going to be risk based on the level of detection. So the identification of an avian influenza virus somewhere in the world is going to contribute to the assessment of the threat level for our study sites.
Okay, you know what? I seriously, there's something wrong with the audio. I can't hear it.
Oh, really? Can everyone else hear me okay?
I can. It's just it's got a little bit of a buzz.
Yeah, I'm okay.
Everything's great.
Okay.
All right.
You're clear here. Okay.
Because one of the points I want to make is that if you do a robust enough wild bird surveillance program in British Columbia, you're going to raise the risk to high every time because we have endemic NAIs. And I think the real risk, you have to factor in the biosecurity of the poultry producers. If you're assessing risk of this moving into poultry, you need to bring in that side of it, including the fact that limited surveillance is being done, and canase can't be the denominator for surveillance in the commercial poultry industry. So if you're asking the question, about detection, you know, your risk based on the level of detection within commercial poultry, it's actually pretty non-existent, other than the fact that we have the capability to detect it once it's in the barn. But I want to say that if you're assessing risk, it's always going to go high because you're always going to find NAIs in wild waterfowl. And there is quite a bit of difference between the low-path endemic NAIs and the European high-path AIs that are being transmitted as high-path. That's a completely different risk profile.
Yes.
So I've struggled with this.
So the WIP is intended to end at the farm gate. So we weren't trying to include the risk factors at the farm level. This was really, it was being used as a model for the Wildlife Health Information Platform for a number of diseases, and we used avian influenza as our model, which was challenging. And so it was intended not to go past the farm gate and really just to look at the risk levels for producers or for the industry in general to maintain their level of biosecurity. The argument being is that they don't want to maintain the same level of biosecurity throughout the year, and that it's better if they don't, because they suffer from, what was the word, biosecurity exhaustion or something. So that was what we were aiming for. We weren't trying to include the level of biosecurity at the farm gate, which of course is really important for transmission from wild birds to the poultry barn.
Okay, but I still say that we'd go to high risk every migratory season then. So I'm not sure how powerful these three different categories of risk are if we always default.
And that might be our what we've determined for avian influenza. We're just as well off with the calendar as opposed to all of this. I agree. So I mean that could be our assessment of the WIP at the end for avian influenza, is that you might as well just use calendar.
Okay, thanks.
Okay, right. So looking at the rest of the WIP now, so for Alberta, the delineation between high and low was quite clear, mostly because of the waterfowl presence. A lot of birds came in this fall. The reports were higher than average, and also a very successful hatch, so a lot of immatures. And so I ranked the migratory season for Alberta at 10 throughout August, September, and October. So the snow ice element, because it was warmer then, the water bodies and the fields are open, so it's a higher threat. It doesn't mean that there was more snow, it actually means there was less snow at that point. And then in Alberta, we had bad weather starting in November, and the birds disappeared very rapidly and didn't come back. And so the threat dropped off a month early. So in fact, the migratory season for Alberta ended a month earlier than expected. Another thing I wanted to point out on here is that the vegetation index really didn't change, and either we have to rethink how we use it or not use it at all. It wasn't very useful. Next slide, please. For the decision matrix for British Columbia, the birds, again, waterfowl presence played a large role, and they arrived more slowly through August and September, but their numbers fluctuated quite a bit. So and they fluctuated when the weather was bad. So I didn't know if that was because the birders weren't out reporting or if that's really what was happening. So I spoke with Gord Gadsden, and he is a birder with the Fraser Valley Birding Association and has done research with eBird data before. And he said that in fact is what happens in British Columbia. They start to gather. When the weather gets bad, they'll move south into Washington State, and they don't have to go very far before they find better weather. And then many will come back again. So that's why it fluctuates throughout the weeks in British Columbia, until January, where the waterfowl presence really falls off, and that's because we had defined that as outside the migratory season, but there was actually still a lot of birds around. So again, you know, that might need to be redefined, and we might say that British Columbia is, you know, fairly high risk throughout these months. Next slide, please. So I guess before we go into the next step, is there any questions or comments about those bar charts now?
So, Michele, just to clarify, the bars there that were for snow and ice were bigger because there wasn't any.
Exactly.
So it's more attractive to the birds, so it's higher.
So it's more attractive for the birds,
okay.
Yeah. Okay, so at the last meeting, we'd introduced the stoplight idea for determining the cutoffs for the changing threat levels. And so the question being, so what cumulative risk score to move the threat from green to yellow and from yellow to red? After working with this data, that just seemed too prescriptive. And next slide, please. I wondered if this maybe wouldn't be a better visual, sort of indicating that there is an indication of changing threat, but that there's a lot of uncertainty around that. Next slide, please. So again, we could take some time for if anybody has any comments or questions, but these questions about at what value would you make a transition from low to moderate or from moderate to high, or do you even think it's possible with these data to establish cutoffs? Do you think it's appropriate? Does anybody want to have any questions or comments before we start the poll?
I think it's just clarification of, from my perspective, the question. So what's the cutoff value to transition from low to moderate threat level? Are you asking for the number?
Yes, so the number from the graph. So really all you can do is look at our 6 months of data, and it may not be enough, but if you have an idea where that might be.
Okay. I think, Andrea, just to clarify too, like on those graphs at the bottom, so they range, the axis goes from 0 to 10.
Yeah.
So really it's where along that axis would you change the threat level from low to medium, and then where further along, presumably, would you change it from medium to high?
And 10 is the maximum possible cumulative sum you could have in a week.
So we'll open the poll so people can chip in. Michele and Jane, based on the risk factors, like through your research on this, are there some that really clearly stand out besides I mean, obviously the presence of the virus is going to be a key thing all the time, but which of these things in risk factor studies really does influence transmission the most? Have you seen anything in the literature that would indicate?
In a way, all of the environmental data really is supporting waterfowl presence and to some degree virus survival.
Yeah.
So it was just really looking to see whether using the environmental elements as well as support the information we get from waterfowl presence, or whether the waterfowl presence is enough, like if that is enough information. So all of them have been shown to be important for changing threat levels over place.
Yeah.
But really there's no literature. I didn't find any studies that looked at changing threat levels for avian influenza over time.
Okay.
And just to extend on that, Andrea, I think really one of the main sort of impetus behind this project was thinking about our years of surveillance data and asking the question really what has changed. Because coming back to Vicki's point, we know that avian influenza is in the wild bird population at high-ish levels every fall. Now, it's usually our local endemic North American lineage low-path viruses, but they're there, and some of them are H5 and some of them are H7. But can we do more with data that are out there already to put some context around those findings and to help sort of establish whether the threat really is higher or lower, and to see what was out there in terms of availability too.
Can I just share with you, because you're talking about the different degrees of, when do you initiate change? And I think the real question is, when does the poultry industry initiate change? In British Columbia, there is a system in place in which the poultry industry will go to their heightened levels of biosecurity based on certain events. And I'm referencing it right now. So for the poultry industry to go from green to yellow, they want a positive detection of reportable H5 or H7 or high path disease in wild birds in the region. So and the regions are defined as Fraser Valley, Vancouver Island, and the interior where the poultry production is. They will only go to red if there's a positive detection on the farm, in any BC farm. So they will also go to yellow if there's a positive detection in an adjacent jurisdiction, and that would be someplace like Alberta. So they will move to a heightened level of biosecurity based on the wild bird detection, but I don't think they're going to go to red because of it. So I just wanted to share with you that's kind of the guidelines that they're using to change their biosecurity practice.
No, that's great, Vicki. Thank you. And presumably the positive on a farm would be in the domestic poultry. I don't think we're testing any wild birds on the farm typically.
That's right.
Okay.
So the transmission has happened.
Yeah.
Okay.
So the next area to consider is how we could best communicate these findings. If this was to move forward, how would you like to have this information communicated? For some, the stoplight or the upside-down pyramid may be sufficient. They just want the final answer. For others, that sort of level of data aggregation, you lose all of the information. So this isn't a real dashboard. I've learned that is an entire discipline on how to create effective dashboards. But this would be the idea to provide all the information as well as the final analysis of what the threat level would be for that week. So any comments or questions about how you like to have information like this communicated?
Hi, Michelle. It's Julie here. I've got a group with me, so we've had some good discussion here. We did have a question about, and maybe Vicki was answering that. When you change the threat level from low to moderate and moderate to high, what is your anticipated impact on the industry? Because I think that would help us define where those levels should be.
I guess it would be an indication for increasing biosecurity, and so for the organic farmers not to let their birds outside, that sort of thing. And it may also be an indication for increasing surveillance in some areas if they choose to spend that money to do so. But that's outside our purview. That would be the decision made by the boards of producers, regulatory agencies, as to what the response would be. But we envisioned mostly an increase in biosecurity levels.
Okay.
Sorry.
Yeah, in terms of dashboard, sorry. In terms of dashboard suggestions, Michele, have you looked at the Canadian Avalanche Association? Because they have a similar rating system, and they have an interesting dashboard where they describe how, you know, even though they change their hazard levels from low, moderate to high, they talk about what that means, and there's an interesting set of visuals there.
Well, that would be a good one because, yeah, even at low, you could still have an avalanche, which is the point here. Even at low, you can still have an outbreak of avian influenza. So, yeah, that would be a good one to look at.
Yeah, because they qualify, and it's qualified in a visual infogram. So each risk level, it's not just a standalone risk is high. It's qualified. What does it mean? And it also, in that term, it qualifies what you should do with that risk level.
Okay. Okay, that would be a good one to look at. Any other comments before we move on?
Well, I'd be interested in what the probability or estimated probability of a transmission would be at these various levels, because if low probability of an occurrence is, let's say, 10 to 40% and high is 20 to 60%, I'm not convinced that I suspect there's a heavy overlap between these different levels. So I'm struggling to see how it's going to inform biosecurity too much. But I find this dashboard approach a lot more useful because it gives additional information that is useful for someone who wants to use it, as opposed to a basic high, medium, low, which might not mean much of a difference. Right.
I don't know how we would calculate probability, excuse me, of transmission at the various levels at this point. I mean, I think to understand how useful or how predictive this is, this would have to run for quite a while. And you might be able to use existing information, but it would still be, like you said, there'd be a lot of uncertainty, so there'd be very wide confidence intervals on that.
Yeah, so I mean, I think it would be helpful if instead of using detection of notifiable AI, if it actually looked at the total surveillance effort as well, because if we use increasing risk as motivation to do more surveillance, all we're going to do is drive more risk because we're going to detect it again. So, I mean, somehow to actually assess the level of knowledge we have by including kind of the denominator data, that would be helpful, but it's awfully difficult to do.
Yes, because we're also including the international information.
No, I get that.
Yeah.
So along those lines, for the poultry industry in BC, their move to action is based on an actual detection. So this, to me, is a different kind of a risk profile that's almost, I wonder if we should kind of name it something different, that it's more of cumulative environmental factors or multifactorial risk versus detection risk, risk based on a detection. So this brings a different element of all of kind of the groundwork is pointing towards a more favorable environment for influenza, as opposed to a detection, you know, a surveillance test. So
yeah,
I
wonder. Honestly, I just feel like we should assume that it's there, whether we've managed to detect it or not.
Oh, absolutely.
We just found the needle that one time.
You know, it's Daniel Schwartz here, and we have worked with CFIA, and we worked on a tool, and I just shared it with Andrea, and we were working on a tool a little bit similar to this, and Abed is on the line as well, and I won't go into detail. I've shared it with Andrea, and she can share it with you, and it was really looking at sort of environmental factors that might, you know, help producers or industry determine, you know, what factors might result in them to, you know, increase biosecurity or protect bird health, primarily, you know, looking really at outdoor flocks. And so I sent that on to Andrea, and I think at the end of the day, you know, we sort of in the Lower Mainland had to take the presumption that there's always going to be a risk from, you know, wild waterfowl, but that it'll increase, as Vicki says, you know, it's going to increase at different times of the year, but at the end of the day, the producers need to maintain a fairly high level of biosecurity. But and even the industry's, currently the industry's use of sort of these scorecards, this red, yellow, green, you know, it depends on what your baseline biosecurity level is. So if in BC, if the baseline is that every producer is washing their hands, cleaning and disinfecting boots, changing coveralls, you know, if that's their green, then, you know, maybe that's higher than what other areas are doing. So I guess it's sort of finding that balance, and I agree with Vicki. I mean, there's one aspect of it is environmental factors that pose an increased risk of wild waterfowl and possible exposure to flocks, and then the whole other issue of, you know, detection and whether, you know, there are other factors changing how it's being transmitted at sort of a bigger level. So I still think there's a number of other, it can become a little bit difficult, I guess, in areas, I guess.
Volume up, loud volume going. No.
So we should probably go on to the next slide. We do have some more questions. So these are for communication of the question is how you would like the weekly results provided, so you can select all that apply. And then whether you've used a threat communication like this in your organization, or whether you think this would support threat communication in your organization for avian influenza, or whether, and for question 8, if you've used a similar tool in your organization, as well perhaps if you've thought of a disease where this might be useful, provide that as an example. We'll give you a few minutes to answer these poll questions.
And so, folks, just as we just have a few minutes left in our allotted time, we can stay on the line because it's being recorded. If anybody has to go in 4 minutes, then you can still tune in for the end of the discussion. But we'll stay on as long as if you want to have further discussion. Michele and Jane, what are the next steps? Sorry, that was a loaded question.
March 31st. I have a report to write.
Okay.
Beyond March 31st. I guess we are looking at the sustainability. If there was interest looking at the sustainability of the WIP, if organizations thought that this would be useful. So that would happen, you know, in April, where we would be looking for some feedback as to whether this was something the poultry industry was interested in, or whether they didn't find that it was going to be particularly useful to them in the long term. Okay. And then try to see how, you know, what the cost would be to sustain it over time.
And I'm assuming that sustaining over time would be all provinces or all poultry growing areas?
I would hope that it would be all poultry growing areas, but we would probably look to see if there was interest in all of the poultry provinces.
Okay.
And I mean, ideally this, like we chose avian influenza as a pilot, we don't have any support or funding to look at expanding it beyond that, but that's something else we have in the back of our mind, is whether we can use a similar approach for other disease threats that may be emerging from wild animal populations.
Okay, so is there anything else anyone would like to add? You can either type it in, or perhaps we just, because it's being recorded, we could just, people could just make comments. I guess, would this be useful?
I recognize that we've bombarded you with quite a lot of information, and I have, Michelle, correct me if I'm wrong, I think Michelle and I really struggle with whether this is useful. I think it was an important exercise for us to go through and to try and bring some of that other environmental and maybe contextual information together, because I think we all do this a little bit in our heads anyway when we're faced with all of this different information. And we were trying to make a more transparent method of doing that in a consistent manner. But I think and Michelle, jump in, but I'm not sure that this is providing information that is going to be of use.
Yeah.
Hi. Oh, go ahead. Go ahead.
I was just going to say, I think for Alberta, that it was useful to recognize that the migratory season ended a month earlier, but I mean, anyone who lived here knew that. It was awful. So, yeah, I'm thinking in lots of ways a calendar and a look out your window is fairly useful.
But I wonder if...
Hi, Michelle. It's Julia here in Alberta. And I got 3 other people here with me, and we agree with what you just said, that Alberta, this might be useful because there's a definite difference in threat level between the seasons. Definitely having multiple years of data would help because each season is so different. Like some years we have waterfowl quite late in the year when things are open. And other years, like this year, the waterfowl get shut down early because of the ice and snow. I think overall, we think something like this may be more useful in a place like Alberta than BC, where the threat level doesn't seem to change much. I think this would only be useful if you get really distinct differences in threat levels throughout the year and from year to year. If you're always on high, you're just going to fatigue everybody, and it's not very useful.
Yeah.
Anything else you'd like to add? My group is nodding their heads.
I think the other thing that we need to keep doing, though, is to keep looking for alternate ways to look at risk other than active surveillance, because there's a lot of information out there, and if we can use it more intelligently, then I think we will get further ahead. So that's just my my soapbox for using multiple sources of information and bringing them together. Okay. So
I guess I haven't introduced the whole team. So myself, and I'm contracted to CWHC. Kevin Brown is the information officer for CWHC and was responsible for rebuilding the database. Colin Robertson is a geographer, and he works at Wilfrid Laurier University, so he did all of our remote sensing for us and made cool maps. Jane, so she works with CWHC as well as PHAC. Patrick Zimmer is the operations officer, and Craig Stephen is the chief executive officer of CWHC. And thank you to Andrea, who's put these 2 workshops together. We really appreciate it.
Oh, my pleasure. And if anybody else, if anybody else wants workshops that you set up that we can bring to a national multidisciplinary audience, then we're more than happy to do that.
Yeah, it was perfect. And next slide, please. And thank you to all of you for coming to 2 workshops and providing all of your wise ideas and contributing to this project. We really appreciate it. We couldn't have done it without you. So, and then
I have a last question, if I can.
Sure.
I don't remember exactly when, but we had a presentation of someone in BC who were working on the study of the influence on sediment to study if it could help to evaluate the threat. And is this work, I remember, if my memory is correct, I remember that the problems was to determine, to identify if the virus that was detected in the sediment was infectious or not. So it was one of the challenge to overcome. But if this work progress in the good way, there is a way to include it in this current tool, but because I see I see an opportunity.
Yes, we agree. That would be an obvious fit if that were to be continued on. And I think, is Michele Coombs still on the line? There are people who are involved in that project who could probably speak to it as to where the progress of that is. But I agree that would be very important environmental information to add to the WIP should it become available on a regular basis.
Yeah, so this is Michele here. And yeah, we are, the study that we're doing is a 2-year study to try and look at avian influenza presence and strain presence, or the detection of these strains in sediment. And yeah, I think it certainly would provide valuable information. We won't know whether the strains are infectious or not, but it's more being used as a tool to kind of get a pool of detections from a larger body of waterfowl rather than having to catch birds or test birds one by one. So it's less a question of is the virus being spread through the environment and more a question of trying to get a more representative sample of what is happening in waterfowl. The big question, though, of course, is what we are detecting in the sediment, is that actually representative of what's happening in wild birds at that time? Or are we getting like a lag between what is happening in the wild birds and when we detect it in the sediment? So we have data collection ongoing until the end of August of this year, and then we're waiting for sequencing results and should hopefully have data coming out within the next year or so, and then hopefully it helps to inform surveillance. But of course, you know, we may find that maybe it isn't a useful tool. So I guess we will see.
Thanks, Michele.
Thank you. Will these slides be available later on as well?
Yes, I'll convert them to a PDF so they're easier to email and include the notes with them.
And Michele, can we post this on the CAS website?
Sure. Yeah, absolutely.
And public or private?
Public's fine.
Okay. Excellent. We will do that, and then everyone can access. And I will, because they're being recorded, I will have the email addresses of everybody that's on today, and so I can send out the link to that for those of you that may not be members of CAS yet.